We have been told so much about milk.
We were told that milk was good for your bones.
I remember my mom always made me drink it.
It was supposed to be very good for my health.
Think about all the milk messages you've heard in your life.
My dad's mother had just the largest hunch in her back, and that was used as a fear tactic.
Sit up straight, drink your milk.
We had people from farms that would visit our elementary school and tell us about the positives of milk.
I remember advertisements when I was a kid that milk is critical for healthy mind and body, strong bones, calcium, things like that. And I think there was a series of TV ads later with celebrities showing their milk mustache.
You remember those Got Milk ads, right? Everyone from Beyonce to Harrison Ford was in them. They had a message you probably also heard from your school cafeterias, your parents and grandparents, even your doctors. You must drink milk to have healthy bones. What's the logic behind all this? Here's the basic explanation that most of us have received. Milk has calcium and your bones need calcium, so make sure to drink your milk. Otherwise, your bones are going to be weak and fragile and you won't grow up big, strong, and tall. But it turns out, milk isn't a magic bullet for healthy bones. I'm Dr. Jen Gunter. From the TED Audio Collective, this is Body Stuff. While I was doing some research for my book, The Menopause Manifesto, I realized that the relationship between milk and bone health is actually pretty complex. I came across a paper with a little tidbit of information that really shocked me. The paper had a graph that showed a surprising trend. Countries where people drank more milk had higher rates of hip fractures. That's not what I would have expected, and probably not what you would have expected either. Why would people drinking more milk have more fractures? I just want to be clear. There's a lot more to this story than the graph shows us. There are many things that affect fractures that weren't incorporated into it. But this was one of those record scratch freeze frame moments for me. Like, what? What is going on here? Is what I know about milk and bones even true? I knew there had to be more to the bone health milk story. If milk isn't the secret to healthy bones, well, then what is? And how did milk and dairy become such a big part of the human diet? If you could only tell someone one super cool bone fact, what would that be?
Oh, only one?
Dr. Joy Wu is an endocrinologist. Endocrinologists specialize in the network of chemical messengers called hormones. And guess what? Bone is actually part of that network.
Both because it is involved in the regulation of minerals like calcium and phosphate, but also because it itself secretes hormones.
So that is super cool, because I think when most people think about hormones, they think about the ovaries or the testicles or the thyroid, but we should be thinking about the bones as well.
Yeah, they both respond to hormones and also produce some hormones.
There's a lot of other stuff you probably don't know about your bones. So let's meet your skeleton. Hello, skeleton. Hello, Jen.
Adult humans have about 206 bones. And the neat thing is every single one is unique in its shape and size, and yet they sort of fit together perfectly.
Our bones do a lot for us.
Bones provide mechanical support.
They're what your muscles are attached to, and they help you move. Without your skeleton, you'd be more like a slug or a jellyfish.
They protect our internal organs.
Your skull protects your brain. Your ribs protect your heart and lungs. Your pelvis protects your reproductive organs and bladder.
They store our minerals.
Like calcium and phosphorus, minerals you need for your cells to work right.
And also it's the site of where your blood cells are made within the bone marrow.
That's right. Your bone marrow makes your red blood cells, your white blood cells, and your platelets, constantly making all the blood cells you need. Now, if I ask you to imagine one of the bones in your amazing skeleton, you probably picture a cartoon bone, white and smooth with little knobs at each end, like you see at Halloween. You're picturing what's called cortical bone. That's the hard outer shell. But there's actually a lot going on inside that hard shell.
If you were then to take a bone and cut through it and look at it under the microscope, there's a second kind of bone, often in the middle, that's called trabecular bone. It's a little like, cutting through the kitchen sponge. You see all those nooks and crannies.
Ooh, so we might use a sponge analogy, like your dish sponge that has like the hard side for scrubbing, the pan, and then the spongier side. You could think of cortical bone as the harder part of the sponge and trabecular bone as the spongy part.
Exactly.
Your bone marrow, by the way, lives within this spongy maze of bone. Bones are dynamic. Our bodies are constantly replacing old bone with new bone. To build new bone, you need calcium. Imagine building bone as a construction project. Cells called osteoblasts are like the construction workers. Hey, Bob. Hey, Jim.
And what that means is they are secreting mostly type 1 collagen out into the surrounding, we call it matrix, so the material that's near the osteoblast. And the collagen is arranged in fibrils.
Picture a scaffold of collagen put together by these osteoblast construction workers.
And then the mineral, which is calcium and phosphate, deposits between those collagen fibrils. And that mineralization procedure is what strengthens the bone, lends it the hardness.
So calcium strengthens and hardens these scaffolds of collagen. Bones also store 99% of your body's calcium. Calcium helps your cells communicate and makes sure your nerves can signal properly. If your body doesn't have enough calcium, it just takes it from your bones, which can make them weak and fragile. So calcium is absolutely essential for your amazing bones to be healthy. And though milk is one source of calcium, it's not the only source. There's also calcium in foods like tofu, sardines, kale, broccoli, cabbage, and leafy vegetables. Lots of people follow vegan or dairy-free diets and get their calcium from these other sources. So when we focus on milk, we exclude all these people. It's important to know that milk is not the only calcium game in town. It's just that milk has historically had a huge cheer squad in the United States because we have a pretty big dairy industry. But milk consumption has dropped here over the past few decades. And milk has even been pretty demonized lately.
We shouldn't be drinking it. It's not good for us. We're not supposed to be able to drink it.
I feel much better drinking almond milk instead of whole milk.
I feel like the rumor I've heard is that you drink milk and now it actually pulls calcium out of your bones or something.
I've heard from my father that as you age, your body starts not needing it and even rejecting it.
We don't have a drop of regular milk in the house anymore.
We have this problematic binary thinking about milk. It's either amazing or it's horrible. Some of my patients have given up milk because they think it caused yeast infections. My friend Tiffany, who's the music teacher, tells me some of her students won't drink milk because they're sure it causes mucus in their throat. And some people even blame milk for their acne.
Milk's a really fraught food, and the fact is, it is a prehistoric food. It's a really ancient food that people have been using for a long time for a very different purpose, to survive on.
More on that after the break. Dr. Christina Warner is an anthropologist who researches how the human diet evolved. She spends a lot of time looking at gut bacteria, the microbiome. She's like the microscopic Indiana Jones. Dun, 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 dun.
Exactly. Thank you. I like that.
As part of her research, Dr. Warner has been digging into a huge puzzle in human evolution: dairy consumption. In the Middle East, they milk camels. In Mongolia, they milk yak. Many cultures ferment milk into dozens of different forms, from yogurt to cheese. Dr. Warner says Genghis Khan's army traveled across the continent with a lightweight, fermented milk curd that could keep at room temperature for up to 2 years.
This ability to produce an energy-dense, lightweight food underlies the success of the expansion of the Mongol Empire.
Why did we develop so many ways of consuming dairy? And how, and this is the real mystery, have some of us evolved to digest dairy as adults? See, milk has a sugar called lactose. To digest it, you need a specific enzyme called lactase. Lactase is fascinating.
Lactase is made in the small intestine. So once you consume milk, if you're producing lactase, the lactose enters into your small intestine and it's digested.
If there's no lactase in your small intestine, you can't digest the milk. So instead, it heads on down to your colon,
where you have trillions of bacteria that will digest it for you, but as byproducts produce hydrogen gas, methane, and carbon dioxide, which contribute to the symptoms of lactose intolerance.
Symptoms like bloating, gas, and stomach cramps. Things that leave you rolling on the floor, grabbing your stomach, and farting. When we're babies, our bodies produce lactase so we can digest breast milk. But as we get older, some of us stop producing it, and we lose our ability to digest dairy.
And that's just part of the normal weaning process for mammals in general. The fact that some populations around the world continue to produce lactase into adulthood is actually a derived trait. It's a mutation. And there was some incredible work showing that these mutations that allow this continued production of lactase has evolved at least 5 times independently in different human populations, predominantly in populations in Europe, also in East Africa and in the Arabian Peninsula. And then the same variant that's found in Europe is also found throughout the Caucasus, northern South Asia, and Iran.
This genetic mutation seemed like the answer to the dairy puzzle. The mutation came first, then people started producing and consuming dairy products. Those with the mutation were more successful and passed their genes along. Mystery solved. But then there was a twist. Something called DNA sequencing was invented. Suddenly, researchers could examine the genes of ancient humans from about 7,000 years ago. In Southern Europe, only a minority had the mutation, and yet they were dairying. And in Central Europe,
they tested Neolithic farmers, and none of them have these genetic mutations.
It took thousands of years after dairying for the mutation to appear. And yet,
we have strong evidence that people are milking animals, producing dairy products, but how are they digesting them?
Dr. Warner, our microscopic Indiana Jones, has been searching for answers in the steppes and plains of Mongolia, where they milk a lot of different animal species.
Cattle, sheep, goats, yak, camel, horses, and reindeer. They make a really wide variety of dairy products, and yet people in Mongolia today do not have the ability to produce lactase as adults.
Most Mongolians are not producing the enzyme that digests lactose, but dairy is a huge part of their diets.
Even today in the countryside, some men consume up to 250 grams of lactose per day in horse milk, which they also then ferment to make a kind of alcohol.
Wait. There's horse milk alcohol?
Yeah, so this is something that isn't that well known outside of Central Asia and Inner Asia. But yes, this is, some people might know it by the name kumis. It's very fizzy and very fresh, but yeah, it's an alcoholic horse milk. And they also distill cow and yak yogurt to make a kind of milk vodka.
It amazes me how people are able to ferment whatever they have to create alcohol. I'm continually impressed by the innovation.
Me too.
Okay, so Mongolians are consuming all this dairy, even alcohol made from dairy. But like lots of other people in the world, most Mongolians do not have the genetic mutation that allows them to digest lactose. Shouldn't they be groaning in pain from bloating and gas after all that horse milk alcohol and yak yogurt? How are they digesting dairy? Dr. Warner thinks the answer might be in the microbiome, that diverse ecosystem of bacteria in our guts.
There was a study a few years ago that was the first gut microbiome study shown for Mongolia, and it showed that they had a quite unusual gut microbiome profile. And one of their unusual features is they have very high amounts of a group of bacteria called bifidobacterium. And bifidobacterium are a milk-adapted bacteria. They're extremely high in infants. And so we're starting to wonder if there's a different adaptation mechanism happening in Asia where people are able to maintain an infant-like state of the gut microbiome to also aid in lactose digestion.
So some adults can digest milk because they have the genetic mutation from thousands of years ago. Some might have this unique microbiome, and some people have neither and can't digest milk. We still have so much to learn about this one mystery in human evolution. What amazes me is that humans seem to have a limitless capacity to evolve with our food. And that's probably one of the biggest takeaways from the story of the human diet.
There is no one perfect human diet. There's many different successful and healthy diets for us. And I think that's really characteristic of our species. And I think that's also what allowed us to survive the last ice age when so many other megafauna, and we're megafauna too, went extinct. It's our ability to be flexible and our ability to handle many different diets.
There was never just one diet among ancient humans. That's why diet fads like the meat-focused paleo diet are nonsense. Throughout history, people ate what they had. Some people ate meat, some people ate fish, some people ate lots of fruits and vegetables, and some people ate dairy. Groups of humans have even adapted differently to the same environment, like in medieval Greenland. Greenland is an unforgiving environment where it's pretty challenging to grow crops. That makes getting enough glucose and other nutrients hard. The Vikings adapted in one way, by setting up dairy farms, but the Inuit were also living there at the time.
The Inuit had a completely different strategy. So rather than focusing on sources of glucose, they consumed large amounts of fat and blubber, which allows their bodies to produce glucose through a process called gluconeogenesis. So in this really extreme environment, you have two different groups who in completely different ways develop cultural and biological adaptations to surviving. And I find that absolutely fascinating.
We've developed many ways to get the nutrients we need. And getting calcium is no exception. There are many ways to do it. Milk might work for some people. Other sources of calcium might work better for other people. But you don't need milk. I spend a lot of time thinking about how to get enough calcium in my diet. That's because my mom actually died from complications of the bone disease, osteoporosis. When you have osteoporosis, you have low bone density. That means your bones are thin, fragile, and susceptible to fractures. Spine and hip fractures are two of the most dangerous complications of osteoporosis. And one risk factor for osteoporosis? Not getting enough calcium. Remember, calcium hardens and strengthens your bone. And if your body doesn't get the calcium it needs, it pulls calcium from your bones, making them weak and brittle. But there's a reason osteoporosis happens to people when they're aging and not when they're young adults. Bones change over our lifetimes. Here's Dr. Wu, the endocrinologist.
As children and young adolescents are growing, of course, bones are getting bigger and also getting stronger over time and increasing in what we call bone mass. So peak bone mass in adults happens in the late 20s, early 30s. After that, there's a very gradual decline, slowly year by year, in the amount of bone that people have.
This is because the balance between making new bone and breaking down old bone changes.
With age, the rate of bone breakdown tends to outpace the rate of bone formation. In women, there's a period of more dramatic decrease in bone density and bone mass in the years right around menopause.
Hormonal changes around menopause are a big reason why there is a higher rate of osteoporosis among women, although men can get osteoporosis too. So you're talking to somebody who's maybe in their 40s or 50s, or a young whippersnapper like me at 54. What would be some of the preventative measures that we could take to protect our bones and protect us from osteoporosis?
I think the most important would really be exercise for all sorts of reasons, but one of them being that it is great for bone health. So regular exercise, averaging about 30 minutes a day, but particularly with an emphasis on weight training or resistance training, maybe 2 to 3 times a week. At any age, exercise should sort of approach a limit where it stretches you, right? Where it challenges you.
Exercise is absolutely critical for keeping your bones healthy. Putting physical stress on your bones by lifting weights or biking or running stimulates osteoblasts. Remember, those are the construction worker cells that build new bone. Hey, Bob! So exercise is a bit like the start of a shift bell at a factory saying, hey boys, time to get working, gotta build some bone. Exercise also increases blood flow.
And so you can deliver more oxygen to the tissues, including muscle and bone. Blood flow in bones is an important part of bringing nutrients to bone and also helping the cells that are making new bone.
For some people, calcium and vitamin D supplements may be another strategy to prevent osteoporosis. Vitamin D's main job is to help your body absorb calcium. But it's important to know that taking extra calcium and vitamin D beyond what you need isn't going to protect your bones.
More is not always better. I mean, I think for both calcium and vitamin D, there have been sort of waves of enthusiasm where maybe people have tended to go a bit overboard.
The amount of calcium you need a day depends on your age. Until you're 50, it's 1,000 milligrams. For women over 50 and men over 70, it goes up to 1,200 milligrams. And this includes your diet and any supplements you're taking.
On average, a serving of dairy products, which is a cup of milk, a cup of yogurt, an ounce of cheese, is about 300 milligrams. So I tell people if you're going to do dairy products, 2 to 3 servings a day would be most likely adequate, because we also get calcium in, for example, green leafy vegetables and other dietary sources.
So what's your favorite calcium-rich food?
I really love all forms of cheese.
Oh, yeah. We should do a bone health tour in France.
Yes.
We have to go in. We're required to sample all the cheese.
Oh, we did this biking tour in the Loire Valley. It was amazing because everywhere you went, there was cheese and biking. So I think my bones were very happy on that trip.
So Dr. Wu and I both love cheese. And milk and dairy are good sources of calcium. They're just not the only source. I also try to get calcium from chia seeds and leafy vegetables and sardines. It's so good on toast. And that's one of those amazing things about how humans have evolved. We can get nutrients from many, many sources.
We are dietary generalists, but more than anything, we are flexible.
We're creative, brilliant, flexible omnivores. We've managed to survive an ice age, make alcohol out of horse milk, and develop not one, but two completely different ways to survive in Greenland's harsh climate. We are constantly adapting to survive. Is there one thing that you hear people talk about, on social media, your friends, or, in the news about the human diet that just makes you roll your eyes or drives you crazy?
Yes, superfoods. There aren't superfoods. There's just foods. There's no magic bullet. There's no one quick fix. I often say that the advice I give is, eat more root vegetables, eat vegetables in general. That's incredibly healthy for you. That no one seems to like that answer.
There are no miracle diets. There are no single superfoods. And looking at human evolution is a great way to bust these sticky food and diet myths. Because evolution shows us there is no one right answer. No one magic dietary bullet for healthy bones. Just make sure you're getting enough calcium and vitamin D. And of course, exercise. Your bones will thank you. Next week on Body Stuff. When the pandemic started, did you look for zinc, vitamin C, vitamin D, or other things to boost your immune system? Then you've probably heard one of the most powerful, pervasive myths out there.
It's everywhere. And it was sort of everywhere before we were in the middle of a pandemic. And then, of course, post-pandemic, the ideas just exploded. And it's actually become, I think, more complicated.
We'll ditch the disinformation and explore the real science of your immune system. Body Stuff is a member of the TED Audio Collective. It's hosted by me, Dr. Jen Gunter, and brought to you by TED and Transmitter Media. This episode was produced by Camille Peterson and edited by Sarah Nix and Lacey Roberts. The rest of the team includes Alice Wilder, Greta Cohn, Michelle Quint, Ban Chang, and Roxanne Hai Lash. Alex Overington is our sound designer and mix engineer. Christiana Parta and Nirja Aravandan are our fact checkers. Special thanks to the people around the world who make such a diverse array of creative foods from dairy. I'm looking forward to meeting all the cheeses I've never heard of before. We're back next week with more Body Stuff. Make sure you follow Body Stuff in your favorite podcast app so you get every episode delivered straight to your device. And leave us a review. We love hearing from our listeners. See you next week.